If you head into the resources section again, you can open up Logisim and open up the file, and also open up the Excel spreadsheet. Now the thing we haven't mentioned so far or talked through is this add subtract button. So we know that we can add and subtract by pressing this button, but we know we can also put in positive and negative numbers. So for example, if we open up the spreadsheet, we could put in the number 7 minus the number 5, which gives us 2, but we could also write in 7 and we could add on the negative of 5 and get the value of 2, or we could have 7 and we could have minus the negative 5, so the minus and the minus cancel to give us a plus, and that would be 7 plus 5 would be 12. So we need to make sure that we can work with both the subtraction button here and also a minus sign, and of course the minus sign could be anywhere, it could be here, and we could have, for example, this value here, minus 7 minus minus 5, which is minus 7 plus 5, which is minus 2. So we want to make sure we've got all of the results, the sign for the results correct, dependent on the plus and minus, the addition and subtraction, and also the plus and minus values. So that's what we're going to talk over in this video. So it's relatively straightforward. If we were to head in, and I'll have a look in here, we can see here that we can write our numbers. So we can write our numbers x minus plus y. Now that's exactly the same as saying x plus the negative of y. So whenever we are using the subtractions, in effect this is equivalent to the subtraction button. When we press the subtraction button, all we need to do is we need to change the value of a positive y to a negative y. So for example, if we had 7 and we put in the subtraction button and we're subtracting off the value of 5, then we can write that as 7 plus minus 5, which is equal to 2. Equivalently, if we were subtracting off the negative value of y, then this would be equivalent to adding on the positive. The two negatives cancel. So for example, you would have 7 minus minus 5, which would equal 7 plus 5, which is equal to a value of 2. So this is what we want to implement. Now, what we actually have here is an exclusive OR gate. So in the adder and subtractor that we have already designed, we know how to do the addition and we know how to do the subtraction. So in order to add this button in, all we have to do is change the value for our y, depending on whether we are doing an addition or subtraction, and whether the value for y is positive or negative. So if the sign bit of y is positive, that is, it's a 0, then all we need to do is simply make it negative, that is, we negate it whenever we do the subtraction. If the sign bit for y is negative, that is a value of 1, then we have to simply negate it in order to make it a positive value whenever we're subtracting. So this one here is the top case, and this one here is the bottom case. And then we just continue on with the algorithm. So it's best seen by example. So let's put an example into the spreadsheet. So if we had the 7 plus 5, then both of these values are positive. Now if both the values are positive, you see that the sign is going to be 0 and 0 in both cases. Now if we were to add on 7 plus minus 5, that's the same as 7 minus 5. So whenever I make this a negative, what you want to do is keep an eye on the y value. So the y value is simply going to change to a value of 1 because it's now a negative. But there's another way for this y value to change to a value of 1, and that is if we actually use the subtract button. So 7 plus minus 5 is the same as 7 minus 5. So when I make this button here negative, that should then change the y value to a value of 1. Okay, so now the y value is changed to a value of 1. And this is us simply implemented the subtraction. So the minus 5 here will give us the same value as the subtraction of the plus 5. Now, equally, what we want to make sure is if we were subtracting off a negative, then two negatives would have to make a positive. So if I was to put another negative in here, you'll see this sign then changing again to a positive value, so it'll change to the value of 0. So that's this here. So if I put in a negative here, it'll change to a value of 0. So in all cases here, all we're really doing is keeping the algorithm exactly the same as it was previously, but we're adjusting the value of the sign for this y value. So let's go ahead in Logisim and we'll design the little circuit that's going to do the addition and subtraction button. Now we can actually get Logisim to do this for us, and this is a handy thing to be able to do. If you ever get stuck with combinational logic circuits, then we can get Logisim to build it for us. So we could go into Project, Analyze Circuit, and we can build an actual truth table here. And then from that truth table, Logisim will build the circuit. So we could put in the first value here. So the first value would be, say, the add subtract button. So we could call that A underscore S. That stands for add subtract. So that's our actual button. And then we can put in the value for our y. So our y is either going to be a value of 0, 1. So it's going to be positive or negative. So we'll just call this the sign of y. So we'll say sy just means the sign of y. And then we can add the output, and we'll just call the output, we'll just call it O for the moment. And then we can go to the truth table. So we're going to have the truth table here. So we're going to have 0, which means addition, and 1, which means subtraction. And the value for the sign for y is either going to be 0 for a positive value or 1 for a negative value. So whenever the sign of y is 0 and we're going to do addition, we just leave that at a value of 0. Whenever the sign of y is 1 and we're going to do addition, again we leave that a value of 1. Sorry, we're going to do subtraction. The sign of y is negative and we're going to do addition, we just leave that a value of 1. So whenever the sign of y is 0 and we're doing subtraction again, we're going to end up with a negative value. But if the sign of y is negative and we're also going to be doing subtraction, then the two will cancel, and when the two cancel, we will get an addition. So that's going to be a value of 0. So this here is just the simple truth table for an exclusive OR. And we can build the circuit. If you click build, it'll automatically build the circuit for us. Now this is actually just a more complicated version of an exclusive OR gate, but we can just take this gate here, and we can use this build. So if I was to get into the top level now, and we get in here, and we go to the add subtract button, you see the add subtract button, it takes in the value of sy, and it gives out the other value of sy. So it's the sign of y, and it changes the sign of y in the output. Now these sign of x, they're not actually connected to anything. They're only just sitting there for aesthetic purposes. It's just to make the whole thing look as if it's a bit more symmetrical. So they're not really needed. And we've got the plus and minus button here. So if we head in here, you'll see all we've got is a sign for our y, and we've got the plus and minus, and that gives us the final output sign that we're going to use. So that's all we need to do for the add and subtract button. It's really quite straightforward, and all we're doing is breaking into the sign of y path and adjusting it depending on the add or subtract button. And the value that comes out is that we call it SBY. And this is the value here that comes out, and it's this value here that we then work with the exponent, difference and swap. Now the last thing we have to take care of here, if you remember back to just the second video in the series, we were looking at how we worked out the final sign of the result. Now the final sign of the result originally was just the sign of the x value. But then we said that if the mantissa, which is inside the brackets here, ended up a negative value, then we had to negate the sign of x. So for example, if the sign of x ended up 0 and the mantissa is a value of 1, which means it's negative, then the output here wouldn't be, for the sign, wouldn't be a positive value, it would be a negative value. Alternatively, if the output for the sign of x was a negative value, which is 1, and the value for our MR inside the bracket, that's the mantissa for the result, was a negative value, again the output would be inverted. So instead of the output for the sign of the result being a negative value, it would then become the inverse of the negative value, which would be a positive value. So we have to take care of this within our design. So let's go and we'll see how we did that in Logisim. So if you look at the Logisim file here, you'll see under this mx minus my. If we head in there, you can see that there's this value mrns. Now this part here chose the smallest between the mx and the my. Now we wanted to choose the smallest between these two because we wanted to use the 2's complement of the smallest value. The reason why we wanted to use the 2's complement of the smallest value is that the answer then would always be a positive value, because we would be subtracting off the smallest value from the largest and we get a positive number. And we wanted to do that in binary because a positive 2's complement number in binary is just the same as a normal binary number. But we also had to take a note whether we had actually to swap these round about, because if we did have to swap them round about, it would mean that the final result would have actually been a negative result. So we need to take a note that the final result would be negative, and we take a note from this point here. So whether this goes high or low will tell us whether the result for the mantissa is in fact negative. So if we then take this here, mrns, we'll go to the top level and we'll go to this little section here called sign. And you'll see that this here simply follows the truth table that we've already looked at, and I'll bring it up just now. So it follows this little truth table here. We've got the sign of x and we've also got the mantissa result, whether it's positive or negative, and it will return either the sign of x or the negation of the sign of x. So let's just go in and we'll see how that does it. So you can see here we've got the sign of x and we've got the negation. And this is going to either pass the sign of x or the negation of the sign of x, dependent on this value mrns. And this will give us our final correct result for the near path. And you'll see here that at the bottom here, we're going to have the result for the near path, which is this SRN. Okay, so this is the output from here, the output from the sign. So it's the final sign for the near side. So that's going to give us the sign for our subtraction on the near side. Now we never had any of that complication on the far side. We talked through in the far side and we've seen that the final value for the sign for the far side is just this SX0. And that's because we knew that the value of the result as soon as we got the two values coming in, because with the exponent value in the far side is going to be greater than or equal to a value of 2. So the sign of the output here in the far side would just be the sign of the largest value of the two inputs. So that's how we work out our sign, and that's covered pretty much everything that we need to know about our basic adder and subtractor structure. But we haven't looked at the rounding, we haven't looked at the subnormal values, and we haven't looked at the special values. So we're going to get into those in the next section. So thank you for listening. I'll get you on the next video. Goodbye.